Imagine standing before a mirror that does not reflect your face, but reveals the memory of existence itself. A mirror that gathers light traveling across billions of years through an expanding universe. What appears before you is not the present, but echoes of a reality that existed long before Earth was born. This is the true purpose of the James Webb Space Telescope. It is more than a telescope built to see farther into space. It is a machine designed to look backward through time, into the earliest chapters of cosmic history. For decades, scientists believed they understood how the universe began. According to the Standard Model of Cosmology, the universe emerged around 13.8 billion years ago in an event known as the Big Bang. In the beginning, space expanded rapidly. Temperatures cooled, energy condensed into particles, and those particles formed the first atoms, mostly hydrogen and helium. The universe entered a silent era known as the Cosmic Dark Ages. Matter existed, radiation existed, but there were no stars to light the darkness. Over millions of years, gravity slowly gathered matter together. Tiny fluctuations became dense regions, and eventually the first stars ignited. From these stars, the first galaxies emerged. Scientists expected this process to be slow and gradual. The earliest galaxies should have been small, chaotic, and irregular. Complex structures were supposed to take billions of years to evolve. The farther we looked into space, the simpler the universe was expected to appear. But when the James Webb Space Telescope began observing the deep universe, something unexpected happened. Regions that once appeared as faint smudges suddenly revealed astonishing detail. Instead of primitive formations, Webb discovered galaxies that looked far more evolved than existing theories predicted. Some galaxies showed rotating disks. Others contained bright central cores surrounded by orbiting stars. A few even hinted at spiral structures, formations that should not have existed so early after the Big Bang. At first, scientists questioned the measurements. Distances in astronomy are estimated using redshift, the stretching of light caused by the expansion of space. If those calculations were wrong, perhaps the galaxies were not as ancient as they seemed. But observation after observation confirmed the same truth. These galaxies were real. And many existed only a few 100 million years after the birth of the universe. In cosmic terms, that is unbelievably fast. It was as if astronomers discovered a fully developed city where only the earliest foundations should exist. The universe was supposed to evolve slowly. According to everything scientists believed, the first galaxies should have been small, unstable, and chaotic. Structure was expected to take billions of years to form. Order should have emerged gradually from cosmic disorder. But when the James Webb Space Telescope began peering deeper into space than ever before, the universe revealed something entirely unexpected. Ancient galaxies appeared far too advanced for their age. Instead of shapeless clouds of gas, Webb discovered massive galaxies with organized structures. Some contained rotating disks. Others displayed dense glowing cores surrounded by orbiting stars. A few even hinted at spiral formations, structures scientists believed should not have existed so soon after the Big Bang. At first, astronomers suspected an error. Distance in the universe is measured using redshift, the stretching of light as space expands. If those measurements were incorrect, perhaps these galaxies were not as ancient as they appeared. But observation after observation confirmed the same unsettling reality. These galaxies truly existed only a few 100 million years after the birth of the universe. In cosmic terms, that is almost impossible. It would be like discovering a fully developed modern city in a place where only the first signs of civilization should exist. And the mysteries only deepened. By studying the light coming from these galaxies, scientists can identify the elements hidden inside them. What Webb found shocked researchers around the world. These ancient galaxies already contained heavy elements such as carbon, oxygen, nitrogen, and iron. But these elements are not created in the Big Bang. They are forged deep inside stars through nuclear fusion. When massive stars die, they explode violently, scattering those elements across space. That process takes time. Stars must form, burn for millions of years, collapse, and explode. Yet somehow, these heavy elements appeared astonishingly early in cosmic history. This suggests the early universe may have been far more active and violent than scientists ever imagined. Stars may have formed rapidly. They may have lived short, intense lives before exploding in massive supernovas. Instead of a calm and gradual beginning, the young universe may have been a place of extreme acceleration and chaos. Then came another impossible discovery. Supermassive black holes. These cosmic giants contain millions or even billions of times the mass of our Sun. Scientists believed black holes needed enormous amounts of time to grow to such sizes. But Webb detected evidence of gigantic black holes existing incredibly early in the universe. Some appeared far too massive to be explained by current theories. To understand this mystery, scientists began exploring radical new ideas. One possibility suggests certain black holes formed directly from dense regions of collapsing matter in the early universe, skipping the normal process of slow growth. Another theory points toward dark matter, the invisible substance believed to make up most of the universe's mass. Dark matter cannot be seen directly. It does not emit light. Yet its gravity shapes galaxies and controls the motion of stars. But perhaps dark matter plays a much deeper role than previously believed. Instead of acting only as an invisible framework, it may actively guide how matter organizes itself. It could influence the formation of galaxies long before visible structures fully emerge. And the shapes of these ancient galaxies raise even more disturbing questions. Many appear strangely organized. Symmetrical patterns. Stable disks. Coherent structures. All appearing during an era when the universe should have been too turbulent for order to exist. It almost feels as though something unseen was shaping the architecture of the cosmos from the very beginning. But perhaps the most profound discovery lies not in galaxies or black holes, but in chemistry. Webb has detected complex carbon-based molecules drifting through deep interstellar space. These molecules are considered building blocks for life. What makes this discovery extraordinary is their age. The light-carrying evidence of these molecules began its journey billions of years ago, long before Earth existed. This means the ingredients for life were already present throughout the universe at an incredibly early stage of cosmic history. Life's chemistry may not be rare. It may be woven into the fabric of the cosmos itself. The implications are staggering. The deeper Webb looks into the universe, the more reality seems to challenge human understanding. Galaxies form too quickly. Black holes grow too fast. Complexity appears too early. Every answer creates new mysteries. Every discovery forces scientists to question assumptions once considered certain. The James Webb Space Telescope has not simply expanded our vision of space. It has transformed our understanding of existence itself. And perhaps the most humbling realization is this: every photon captured by Webb has traveled across billions of years to reach us. Those ancient signals began their journey long before Earth formed. Long before oceans existed. Long before life emerged. Long before any